Okay, so number 1 on this Unit 4 exam review asked me to sketch the curve and then shade the region that represents the area of the region enclosed by that function and the x-axis. So I'm going to do those two things first. First, let's sketch it. One thing that I do almost every time is just get a quick XY table kind of in my head. I don't really write it out, but I'll write it out for you just so you can kind of see what I'm thinking. So if I'm going between the x-axis and that curve, and this is a negative quadratic function, that tells me that I'm not really going to have to go beyond 0 here, because if I go into the negatives, let's think about what happens. If I go to -1 right here, if I plug -1 in here, I get -4 minus a +1 when I square it. Well, -4 minus 1 would be -5. So that's going to put me below the x-axis. So I'm not too concerned about that side. Instead, I'm worried about like what's happening up here. And I know it's going to be shaped kind of like that, an upside down parabola. So let's plug in 0 and just see what happens. If I plug 0 in for both of those, I get 0. So 0, 0 is a point. If I plug in 1, I'm going to get 4 minus 1, which is 3. So at 1, which is right here, it's kind of hard to see on this video, but that would be 1, and then 3 would be right here. So right there. And then if I plug in 2, this would be 8 minus 4, which is 4. So at 2, I have 4. So then at 3, this would be 12 minus 9, which is 3. So I'm coming back down at that point. So I'm right here. This is my up. So it looks like this was my maximum. And then I'm coming back downward. So this should be a 0 right here. Let's check it just to be sure. That would be 16 minus 16, which is 0. So that's the basic shape here of my parabola. So it goes down this direction and goes down this direction. And like I said, I'm not too concerned with this part down here, but later I am going to have to think about that, so I'll talk about that once we get there. Okay, so that was sketching the curve. Then shade it, the region between that and the x-axis. So I'm just shading this part right here all the way down to the x-axis. Okay, so A and B are taken care of. Part C says write the definite integral that represents the area of the region enclosed by that and the x-axis. So if it's a definite integral, that means I am putting numbers on it, right? So I have an interval that I'm thinking about. So the integral in this case, if I'm going just between the x-axis and that means I'm going exactly from 0 to 4. I don't have to worry about anything beyond that. So my interval is from 0 to 4. And then I'm taking the integral of this function. So that's just 4x minus x squared. And then dx, don't forget your dx on the end. I would also always put parentheses around your function. That way it's not just dx attached to the x squared, it's the whole thing. Okay. Then part D is asking me to use the left sums to approximate the area of the region between the x-axis and the function on the interval 0 to 4 using 4 subintervals. So in other words, this shaded area, they want me to use the left sums. What that means is I'm going to create rectangles in here, and the left endpoint of that rectangle, that top left corner, should be what's touching my curve. Okay? So if I'm going from 0 to 4 and I have to use 4 subintervals, that means I'm using this as 1, this is 2, this is 3, and this is 4. So I've got exactly 4. So I'm just going to go ahead and make some dividers in here so that you can see what I'm talking about. So there's 1, 2, 3, 4 subintervals. But now I have to think about the left endpoint being on my curve. So right here is my first one. In other words, the height of that one is 0. This right here would be my second one. So the height of that one was 3. This one, the height of it is 4. And then this one, the height of it was 3. So the left endpoint on each of those rectangles is on my curve. Okay, so then I have to actually use those to find the area. Okay, so the area then would be the area of each of these rectangles added up. So first of all, the base size of all of these is just 1. It's from 0 to 1, and then from 1 to 2, 2 to 3, and so on. So that's a 1. So the base is 1. The height in this first one is 0. So base times height. Plus the second one, base was 1, height was 3. Plus the third one, base was 1, height was 4. Plus my last one, base was 1, height was 3. So there's each of my things added up, gives me a 0 plus a 3 plus a 4 plus a 3, which gives me 10. And I always say units squared when I'm talking about area, just so that I've got my units covered. If you just said 10, I would probably count it, but just be aware that on the AP exam, if this was a free response question, you would have to say units squared. You would get 1 point for that. Okay, part E, they want me to use the midpoint rule. And on this one, I want you to be really careful because this one says use the midpoint, which basically means I'm using the middle height of each of these rectangles, right? Except this time, they want the area between the x-axis and the function, but it's on the interval from 0 to 6 this time, and I want to use 3 subintervals. So I want you to be really careful with this one. From 0 up to 6 means I'm actually going to have to extend out 2 more spots. So there's 5, there's 6. 1, 2, 3, 4, 5, 6. Which means I may have to deal with some of this down here. I know that this keeps going, but the area between that function and the x-axis on this side would be down here, which is negative. So we have to think about that. The other thing we have to think about is we're talking about 3 subintervals here. So if I'm going from 0 to 6 and I need 3 subintervals, that means I'm going to have 1 right there, 2 right there, 3 right there. So I'm kind of breaking this up in like my my base of each of my rectangles this time is going to be 2 because I'm doing chunks of 2 here. So there's 1, 2, 3 subintervals. Okay, so my area this time is going to be base times height on 3 different subintervals. So I'm just going to write it out like this so that I have each one of them. So there's my 3 subintervals. The other thing that I know is that my base on every one of those is 2. The height is the part that I don't know. So now we need to think about, we're using midpoint rule. Midpoint of each of those. So here's my first subinterval right here. The midpoint of that is at f of 1. So f of 1 is what I'm looking at for that one. The second one, that subinterval that I'm talking about right here, would be the midpoint is 3. So that's when I'm talking about f of 3. And then that last one, this subinterval, wherever it ends up, the midpoint of that is 5. So I'm looking for f of 5. Well, I already know what f of 1 and f of 3 are because I already did that up here when I was graphing. F of 1 was 3 and f of 3 was 3. So the height on each of those was 3. The height on my last one is one that I have not thought about yet. So I have not plugged in 5 to see where it was at. So let's do that real quick. So f of 5 would be 4 times 5 minus 5 squared. So that gives me 20 minus 25, which is negative 5. So f of 5 is negative 5. And that makes sense because any area that's below the x-axis is negative area. So this is my positive area, this is my negative area. So the question is there more positive or more negative in this case? On that subinterval, in that interval, would it be positive or negative? So let's check and see. So this would be 6. This one is also 6. And then this one is negative 10. So this one ends up positive because my positive value kind of overtakes my negative value. So this is 12 plus a negative 10, would be 2. So the area in that case is 2 units squared. All right, part F, last one. They want me to find the average value. Now, I made a little note to myself. The average value is on page 321 in your textbook. So if you want to go back to that, you can look it up. But average value told me that to find my average height of what was my overall average height in here, that's what that's going to tell me. So this is how I find that. I do my 1 over b minus a times the integral from a to b of my function dx. And that subinterval, or this, not subinterval, the interval is your a and your b values. So this in particular, this one would be 1 over 4 minus 0 times the integral from 0 to 4 of my function dx. Okay, so then I'm going to actually find this integral. So this first part is 1/4, that's easy. The integral of 4x would make that x squared, and then divide this by your new exponent, so that would make that a 2. Minus, this would become x to the 3rd, and I would divide my coefficient by my new exponent, which would be 1/3. And remember, you're finding this integral from 0 to 4. So I'm not doing a plus c on there. I'm actually plugging in values and finding the answer. Okay, so that means I'm going to do 1/4 times plugging in 4 first, and then plugging in 0 and subtracting those two outcomes. So first, let's plug in 4. So this is going to be 2 times 4 squared minus 1/3 times 4. I'm going to take all of that, and I'm going to subtract away what I get when I plug in 0. So 2 times 0 squared minus 1/3 times 0 cubed. Oh, I didn't put cubed on this one. Glad I caught that. Okay. So the good thing in this problem is this 0 and this 0 makes this whole thing just cancel out. That's all just 0. So I really just have to figure this one out and then multiply it by 1/4 or divide it by 4. Okay, so that means I'm going to have 1/4 times, this would be 16 times 2, which is 32, minus 4 cubed is 64, and then 1/3 of that is 64 thirds. So I'm just going to write it like that for now. And then let's simplify that a little bit further. I'm going to multiply through this 1/4. A fourth of 32 is 8. Minus a fourth of this, that would make that, let's see, 64 over 12. Let me write that out like that. So I just multiplied straight across there. But that'll simplify. So this is really going to be 8 minus 64 over 12. 12 will go into 64, let's see, 12 will go into 64 4 times, 5 times. 12 times 5 is 60, right? So that'd be 5 and 4/12, which would be the same thing as 1/3. Sorry, I'm really having to think hard about this today. And then 8 minus 5 1/3 would give me 2 2/3 left. That'd be 7, 8, yeah. So I'm getting 2 2/3 as my average value. And remember, that is actually talking about a height. If you want to know what that actually means, we're not talking about an average area. We're talking about the average height of that area that you're talking about, that 0 to 4. Okay, so 2 2/3 would be my answer there. And I think that's it for number 1. That's a lot, though, for number 1. So take your time on that one and make sure you understand each step for the full points.